So in this room today, we got packets and frames. Don't mind my uniform. Got a fire guard soon, so finna get this room pushed out for y'all. And like it says, understand how data is divided into smaller pieces and transmitted across the network to another device. What are packets and frames? Packets and frames are smaller pieces of data that, when forming together, make a larger piece of information or message. However, there are two different things in the OSI model. A frame is at layer 2. The data link layers mean that there's no such information as IP addresses. Think of it as putting an envelope in with another envelope and sending it away. The first envelope will be the packet that you mail, but once it is open, the envelope still exists and contains data. This is a frame. This process is called encapsulation, which we discussed in room 3 OSI model. Y'all can check out my video on that. At this stage, it's safe to assume that when we are talking about anything IP addresses, we're talking about packets. When encapsulating information is stripped away, we're talking about the frame itself. Packets are an efficient way of communicating data across network devices, such as those explained in task 1. Because this data is exchanged in smaller pieces, there is less chance of bottlenecking occurring across network than large messages being sent at once. For example, when loading an image from a website, this image is not sent to your computer as a whole, but rather smaller pieces where it's reconstructed on your computer. Take this image below as an illustration of the process. The cat picture is divided in 3 packets, right? So it's sending it through packet 1, packet 2, packet 3, which makes the whole picture, right? You know, if one of these packets doesn't make it through, then you don't have a whole picture. Packets have different structures that are dependent upon the time of packet that is being sent, as what we come to discuss. Networking is a full standard of protocol that act as a set of rules of how the packet is handled on a device. With billions of devices connected on the internet, things can quickly break down if there's no standardization. Let's continue with our example of the internet protocol. A packet is using the protocol will have a set of headers that contain additional pieces of information to the data that's being sent across a network. Some notable headers include time to live. It has expired timer for the packet not clog up your network if it never manages to reach a host or escape. Checksum. This field provides integrity of checking for protocols such as TCP, IP, if any data is changed. TCP is another form of the OSI model. I do need to make a video on that. There should be a room on it if not, but it pretty much just has 4 layers instead of 7 layers, and it's more commonly used. This value will be different from what is expected, therefore corrupt. Source address, IP address of the device that packet is being sent from, so that data is known where to return it. The device's destination address, the device IP packet being sent to, so data knows where to travel next. What is the name of a piece of data when it does have IP addressing information? A packet. What is the name of piece of data when it does not have IP address information? It's a frame, right? Too easy. Huh? Let me see. What am I looking at here? Okay. Okay, pretty much what I just said. Making sure. I seen the 3-way handshake and I was like, I thought this was trying to say no. It's just saying. Anywho, TCP transmission control protocol. Pretty much what I said in the last slide. Very similar OSI model, and consists of 4 layers. Arguably, just summarized version of OSI model. The layers are application, transport, internet, network interface. What I said already. Very similar to how the OSI model works, information is added to each layer of the TCP model as pieces of data or packets traverse it. As you may recall, this process is known as encapsulation, where the reverse of this process is decapsulation. So maybe I don't need to make a video. Maybe this will have us tell you all you need about TCP. Who knows in the future. Don't want to waste your time. Thing about cybersecurity is it's so much information to take in. You just want to be able to recall it, unless your specialty is something specific in programming or whatever you're doing. One definition feature of TCP that is connection based, which means that TCP must establish a connection between both client and device acting as a server before data is sent. Because of this, TCP guarantees that any data will be received on the other end. This process is named the three-way handshake, which is something we'll come on to discuss shortly. A table comparing advantages and disadvantages of TCP is located below. Guarantees the integrity of the data. Capable of synchronizing two devices to prevent each other from being flooded with data in the wrong order, performs a lot more process for reliability. The disadvantages will be requires reliable connection, I guess. Yeah, you know, you gotta have the whole thing sent right. A slow connection can bottleneck another device. Okay. TCP is significantly slower than UDP because more work computing has to be done by the device using this protocol. Wasn't okay, because you have UDP and TCP, right? Yeah, maybe I should. TCP packets contain various sections of information known as headers that are added from encapsulation. Let's explain some of the crucial headers in the table below. I'll let y'all read this. I don't really want to read all this shit. Source port, destination port, source IP, destination IP, sequence number, acknowledge number, checksum data flag. Y'all can read that, pause it. Next, we will discuss some of the three-way handshakes, terms given for process cyber connection to two devices. Three-way handshake connection uses few special messages table. SYN. Y'all can read this. I pretty much know it. Actually, I guess I can recoup myself. You can always recoup yourself, right? Send message is the initial packet sent by a client during the handshake. The packet is used to initiate connection and synchronize the two devices together. Send/acknowledge. The packet is sent by receiving device/server to acknowledge the secrecy attempt from the client. Acknowledge just means that it was acknowledged and that it's allowed it pretty much. Data, once the connection is established, data such as byte files sent via the data message. Fin, this packet is being used to cleanly, properly close the connection after it's been complete. This packet abruptly ends all communications, RST. Alright, so just a simple picture right here. Alice is going to do it. Bob is going to send and acknowledge, and then Alice will acknowledge, like confirm that she will accept what has been acknowledged back from him, right? Any sent data is given a random number sequence and is reconstructed using the number sequence and incrementing by one both. Computers must agree on the same number sequence for data to be sent in the correct order. This order agreed upon during the 3 steps. Y'all can read this. Pretty much just went through it, right? Device. Let me read it. Client here, my initial sequence synchronized with 0. Here number synchronous with 5,000, and I acknowledge number sequence. Fuck, I'm there. I acknowledge. Client sender 0, final whatever. Initial number sequence 0. Client sender. Fuck, I don't remember what these numbers are. And it's not really saying. Let's quickly explain the process behind TCP closing a connection. First, TCP will close the connection once the device has determined that the other device has successfully received all the data. Because TCP reserves system resources on a device, it's best practice to close TCP connections as soon as possible. To initiate a closure of TCP connection, the device will send a FIN packet, and the other device, of course, with TCP, the other device will have to acknowledge this packet. Let's show the process using. All right, so Alice, to close it, she's going to send a FIN. He acknowledges, does another FIN. Then she acknowledges all this so she can confirm her action. Right? Yeah. Has sent Bob a FIN because Bob received this. He let Alice know that he's received it, and he also wants to close the connection using FIN. Alice has heard Bob loud and clear and will let Bob know that she acknowledges this. Right? What is the header that ensures integrity of the data? Checksum. If I went back up, I could have, found it. like I said in cyber, bro, you're not gonna remember most of this stuff off the top of your head, right? It's so much. There's so many things, so much stuff. Like, but if this is your specialty, you should know it off the top of your head. Provide the order, three-way. What is it? Send. The three-way handshake is gonna be send, then send/acknowledge, then acknowledge, right? Alright, boom, done with that. Help Alice reassemble little task. So we're gonna do. Can you hear me, Bob? Yes, I can hear you. Okay, great. Now let's do. Cheesecake is on sales. After which we know he hears me to do the data. We could do a. Oh no, I think it's a yeah. They never said anything about repeat. The fuck, trying to trick me. All right, and then, okay, I hear you. And then, okay, Finn, I'm all done. Yeah, me too. Then I'm gonna acknowledge again, right? Then you get the flag. Too easy. UDP, IDP. Yeah, I don't think I'm gonna make a room on a video on TCP. It's pretty much just says it all. Close it. UDP, user datagram protocol. So this is like this is what you would use if you weren't using TCP. So TCP is also a module, but it's also a way to send data. So it's if you hear TCP, it can be two things: either the summarized OSI model, which is TCP and only has 4 layers, or it can be just something to send data. Unlike its brother TCP, UDP, stateless protocol that does not require constant connection between the two devices for the data to be sent. For example, three-way handshake does not occur, nor are there any synchronicities between the two devices. Recall some of the comparisons made about these two protocols. Room 3 made a video. UDP is used in the situations where applications can tolerate data being such as a video streaming or voice chat, or in scenarios where unstable connections is not end at all. A table comparing the advantage disadvantage UDP is located. Let's look. UDP much faster. UDP leaves the application software to decide if the control how quickly packets are sent. UDP does not reserve a continuous connection on a device. TCP does. Disadvantage. UDP is not going to care if the data is sent at all, so you could receive like not all the packets and it will still come through and you'll be like, what the fuck is this? So it's quite flexible to software developers in this sense. This means that unstable connections result in terrible experience for the user. So just kind of like if you're watching a show or something, you know, you don't need all the packets to come through, right? Or playing a video game. That's what you would use UDP for. As mentioned, no process takes place in setting up a connection between two devices, meaning that there is no regard for whether or not data is received, and there are no safeguards such as those offered by TCP tests such as data integrity. UDP packets are much simpler than TCP packets, fewer headers. However, both protocols share some standards header which are annotated on the table below. Y'all can read this. I need to hit chow soon. And I have FireGuard soon. Next, we'll come up to discuss how the process of connection via UDP differs from something such as TCP. We should recall that UDP is stateless and no acknowledgement is sent during a connection. Diagram below shows a normal UDP connection between Alice and Bob in real life. Normal UDP connection, right? Alice and Bob makes you think, right? Bob's gonna request, gonna response, get another response. So just a lot of responses. User datagram protocol, type of connection is UDP, stateless. What protocol would you use to transfer a file? Definitely TCP because you want the full file to come through, right? So what protocol would you use to have a video call? You know, it can lag during the video call. You don't need every frame in the video call. So it's going to be UDP, right? Ports. Let's see. We'll read this before doing it. Perhaps aptly titled by their name, ports are essential point in which data can be exchanged. Think of a harbor and a port, shipping which to docks at the harbor. Yeah, so If you want to, alright, the harbors, the ports, and the ships are the fucking plugs in, pretty much, right? And if you want to, if the boat wants to dock there, you got to see if any ports are available to use, because there's a lot of ports, but not infinite. These ports can enforce what can park and where. If it isn't compatible, cannot park here. Also, your boat's too big, get out of here. Just not compatible. Networking devices also use ports to enforce strict rules when communicating with one another. When a connection has been established and recalling the OSI model, the data sent or received by device will be sent through these ports. And computing ports are ports go through 0 through 65,535. Because ports can range from anywhere between these numbers, there quickly runs the risk of losing track of where application is using what port. Busy harbor is chaos. Thankfully, we associate application software behavior with standards such for rules. For example, enforcing that any web browser data is over port 80. Software developers can design a web browser such as Google Chrome or Firefox to interpret the data the same way as one another. This means that web browsers now can share one common rule: data sent over port 80. How the browser look, feel, easy, designer. While standard rule for web data is port 80. Few protocols have been allocated to standard rule. Any port that it is within 0 and 1024 is known as a common port. Let's explore some of the options below. FTP file transfer protocol, port 21. Y'all can read the description. I've already done this. Secure shell SSH can be 22. Hypertext transfer protocol HTTP 80. Hypertext transfer protocol HTTPS secure. It's gonna be 443. Server message block SMB 445. Remote desktop protocol RDP 3389. All right, we have commonly a couple more protocols that you can find. Right. What's worth noting here is these protocols follow standards. That is, you can administer. If you are curious what this IE means, all it means is that is. So only follow the standards protocol, i.e. you can administer. Follow the standards, that is, you can administer. What is the standard running web server? 8080 instead of the 80 standard port. No, however, application would presume that standards being followed, you have to provide a call-in along with the port number. Open the site attached. All right, now we do the site right. What do I do? Bro. Open the and connect the IP address. Okay, bro. See, you just gotta read it sometimes, even if you don't want to read it. And, oh my god! As simple as that. You put the fucking port in the IP address and you get a flag. Alright, continue your learning. Alright, that's done with the room. Hopefully y'all learned something. This is definitely valuable information just starting off in cybersecurity. So yeah. I hope y'all enjoyed the room.